All right. So welcome you all to ROS-Industrial Conference 2023. First time ever outside Stuttgart. So today I'll be talking something about building a reference robot cell for ROS2. This is part of a new project what we started at IPA called AI Matters, which I'll get into in the future slides. So before I talk about the project, something about Fraunhofer, if you guys don't know already, one of the world's leading applied research organization, founded way back in 1949. Yeah, you already can see that it's a very big institute. We have had around 30,000 employees, and we are just one among these 76 institutes. Yeah, so quite a high number of revenues what we generate, 2.5 billion, and yeah, most of them are industry-oriented services what we provide for the industrial customers. So these are slightly old numbers from 2021, total budget of about 82 million euros. We have had about, so far 1,000 projects of industrial customers each year, which is, I think, impressive. And yeah, it also creates patents, and 5 are already in Germany, basically. So talking about my department, so there are about 8 teams now. I think this year we have added a new one called safety. But I think most of these you might be aware of if you have been working with IPA in the last few years. Quite a decent number of employees, 70. We have groups within the department like picking and packing. Now one group is like specifically focusing on welding applications. Industrial service robots, assistance robots. My group, which are present here, is basically working in the field of software engineering, and yeah, other groups like assembly, automation. So IPA, if you know that it has been involved with ROS since its early days, way back in 2009 or so, couple of our colleagues did an internship at Willow Garage. And around the same time, we were already working on our mobile platform called CareRobot. So once the colleagues came back from Willow Garage, we thought of, we definitely saw potential in ROS back then and thought of applying it on the CareRobot platform. And since then, we have been actively working on in this topic. And soon after SWIRI in 2012, IPA followed in the ROS-Industrial Consortium path by establishing the consortium in Europe around 2014. And yeah, since then we have had quite a few EU projects or which were focused directly on ROS, right? And simultaneously, you can see that quite a few platforms within IPA was also focusing either directly on or using ROS in some or the other way. So also the new platform, what you see, CareRobot 4, also the navigation stack, perception stacks, and all these were using ROS quite extensively. Also, one of the projects that came out, ROS model, maybe if you have heard my colleague Nadia's presentations, it came out while she was working with ROS on CareRobot platform. Right? Also, projects like PyTask, probably not throughout, but it does use ROS in parts, which is a project about force-based assembly applications. Also, quite a few spin-offs that came off from IPA or my department. 4 of them so far. One of the earliest ones was Mojin Robotics, which basically sells the CareRobot 4 platform to especially these electronic storerooms and stuff like that. DragonBot, which is basically for easy programming. Last year, they were bought by Keba Automation. And one of the latest startups is basically Node Robotics, which is mostly into cloud navigation, which is basically hardware independent software basically. Right, you can have a fleet of robots all from different vendors, and they can navigate in a common warehouse area basically. All right. Some of the ROS-based technologies, again, some of them use ROS extensively. Some of them use ROS only in parts. Last year, there was a video released for cabling, which is basically for cabinet cabling within cabinets. You are basically routing the cables, pressing them in these slots, what you can see. Quite a complex application, which was quite impressive. Yeah, again, the second one is basically force-based assembly. If you have to plug in some parts into, I don't know, engines or stuff like that, it only needs the initial location, and based on the force feedback it gets, it can assemble the parts basically. Navigation we have been working on for quite a long time. Also, one of the new topics, which is, I think, started since last year, is agriculture robotics. We have had indoor navigation since long, but through this direction, we have been looking into outdoor navigation for the first time. And the group has been also working on an outdoor mobile platform, basically, which is quite an impressive size. They are still working on it, still experimenting with sensors, manipulators, which will help pick up weeds or some kind of vegetation from the fields. It's still quite an active topic. Swiri, which was Swiri and few others who are present here, have been working on the scan and plan application. And IPA was also involved for a short duration on that project. But if you have more questions, there is Matt and Heis who have been working on this topic for quite some time. Do you have the same problem? So,
well, I think there are some different animations running on those videos.
one by one? Or? I think something changed. Like it has a mind of its own. Doesn't like to be interrupted. Okay, I see something changed. Great. Okay, so that was a bit about Fraunhofer and Fraunhofer IPA in short. Coming to today's topic about basically building a reference cell for ROS2. The idea behind this is basically this. So the idea behind this is basically a project called AI Matters, where we are building testing and experimentation facility for customers, for our consortium partners and customers to test the latest technologies in robotics and automation. So you can see that it's quite a big consortium. I think somewhere around 24, if I'm not wrong. 25. It has basically, it's spread all over Europe with 7 facilities. Today I'll be focusing only on Germany, but you can see that there are other partners involved with their own mini islands basically. Right? Total funding of 60 million, quite a big project, which is running for about 5 years. So yeah, quite a lot of stuff that you can expect to come out of this project, basically. Also, the project, the way it is structured, is that partly it is funded by EU, and partly will be funded by the member state, basically. So in case of Germany, it will be Baden-Württemberg. So what we will do here is basically create some kind of a catalog of services which the customers can choose from for what kind of applications they want to test or experiment based on what hardware we provide in these testing facilities. So of course, we kind of brainstormed and also did a survey. So we have some idea of what are the most popular kind of applications people would want to test, and based on that, yeah, we'll set up these facilities, basically. Yeah, so the idea behind the title of the topic, that is basically reference cell, basically is coming from the second last point, is basically where we are trying to create some kind of standardized test and experimentation services. So for this, we'll try to have some kind of standardized hardware where you can basically, yeah, customize based on what kind of application you're working on. It should be easily plug and play, not only in hardware but also software. Right. So shortly talking about the German node, we have 4 partners involved there, IPA being the leading leader. And there is also a research production facility which is based quite close to the IPA campus, which is called Arena 2036. There is also University of Stuttgart and PTB, which is basically a German testing institute, which is basically for physical hardware. Well, there is no animation on this slide. Okay, great. Yeah, so I think I've already mentioned few points in the previous slide, so I'll be focusing only on the German node right now. Yeah, so as I mentioned, 4 partners. Fraunhofer IPA is the leader of this node. EU provides 50% of the funding, and Baden-Württemberg, which is the member state, will be providing the remaining 50%. So the total funding what the German node or IPA receives is around 6 million, and out of which quite a decent number of money, which is about 2.5 million, will be spent into creating these facilities in terms of buying hardware and also setting up, let's say, scenarios, right? So a scenario could be warehouse where you want to create logistics application with mobile robots moving around, picking up objects from the stack and transferring it to some other location. So yeah, also production lines, for example. So whatever hardware we are or facilities we are planning will be finally set up in Arena 2036. Yeah, so if you are ever in Stuttgart at IPA, yeah, you should be able to visit Arena 2036 as well. And hopefully, yeah, the facilities will be open for the customers in Q3 next year. All right. So yeah, this is just an initial layout of how these facilities might look like, or let's say, what would these facilities include? So basically, most probably there will be simple production lines, probably with 2 or 3 robots with a conveyor belt doing some simple assembly tasks, or right. There will be also provisions for collaborative applications or collaborative processes, and also some kind of enclosed facilities as well, where you don't want human collaboration. For example, you're trying to create safety zones, for example. There'll be facilities for mobile robots, which I already mentioned in an example of being warehouses, with also some space for like storage of goods, or I don't know, some kind of simple shelves from which the robots can pick up these objects. Since the name of the project is AI Matters, we'll definitely need quite a few compute clusters as well. Most probably, I think the capacity for these compute structures may not perform, may not be enough for, like, say, extremely large networks, but for some basic machine learning, I think this should be sufficient, I suppose. And yeah, also some labs for vision processes where you can generate data for yeah, machine vision based applications. Yeah, so we tried to create categories of what these infrastructures and test beds might be. So focusing mostly on the robotics part, what are the test beds available for that would be, let's say, manufacturing test bed, which is trying to recreate a production line. Robot assembly, yeah, as the name says so. Also a robot behavior test bed. So for example, sensors which measure the robot's behavior, let's say, for example, accuracy of the robot. And similarly for mobile robots as well. And yeah, also some welding test bed as well. So to create or to provide these facilities, we will need some kind of standardized robot cells, right? So what kind of cells do the customers expect from us? So we did a survey, I suppose last year, if I'm not wrong. Again, not a lot of responses, so we cannot say this is what the entire industry demands. Quite a short, let's say, island to pick from, but this should give us an idea of what yeah, the customers are looking for. So of course, since we are talking about, let's say, production lines, they are looking for serial link manipulators, which is, yeah, has a reach of, let's say, more than 1 meter, payload of 10 kilograms. Most commonly expected robots were UR, ABB, FANUC. Since we are talking about, so most of these test beds will be supporting ROS2. The last name probably may not happen. Yeah, so sensors, RGBD 4-stock sensors, which may or may not be mounted on the end effectors. Some kind of grippers, and also some kind of peripherals which can communicate with these external devices. Also, we asked them what kind of applications they would want to test, which you can see in the bar graph, most commonly being pick and place and assembly applications. So I think that's not a big surprise there. So these are the initial robots, what we are going with. Of course, we have already listed few more. I think Vishnu, who is sitting on the back, has been working on this reference cell. So if you have any more questions, what kind of hardware we are planning to buy, or what the outcome might look like, please get in touch with Vishnu. Yeah, so according to the survey, these robots matched all the requirements, and more importantly, they also have ROS2 drivers. Yeah, but we are planning to buy more hard robots than this. Yeah, we'll also provide some kind of PLCs in the robot cells as well. For now, we have selected these two. PLC Next, which basically Rishav, one of my colleague here, has worked on in basically creating a ROS bridge, where, yeah, if there is some kind of software running on the PLC, you can read the data through ROS messages, basically. So there is some kind of ROS bridge available, probably still in very early stages, so you cannot do something really fancy on it. But yeah, you should be able to interface it with ROS in some way. And also, what we are looking into is Bosch Rexroth's ControlX, which allows you to install Docker images directly on the PLC. Yeah, also few people in the crowd here are working on it. But yeah, let's wait for the announcement in that case. All right. So that was about the hardware itself. We'll also try to create designs for a versatile cell itself. We are still in the process of designing, or let's say creating a specification of what this cell should include, what should be adaptable, what should be removable or replaceable, what kind of hardware would you want to place in there. So what kind of, I don't know how to call this, but interfaces this needs to have. I think apparently this is kind of becoming a standard now for welding applications, is the welding tables in Germany. And yeah, which is basically quite easy to mount, first of all, the robot itself, but also to move around the workpiece. You don't have to drill holes while moving around the workpieces. So most probably this will be provided in the cell as well. But yeah, we are definitely looking for some feedback, because this is still in an early stage. If you have certain requirements or if you have certain expectations, you can get in touch with my colleague here, Bjorn Karl, who is basically yeah, one of the leading guys in this project, basically, along with my colleague Christoph. Yeah, so if you are expecting something which you did not see on the slides here, which you would want to test or have a cell for, or to test a process, please get in touch with him. Yeah, so what do we offer? Basically, there are some things that will be open sourced through this project. Is basically the CAD itself about the reference cell, BOM for the reference cell. So if you want to create your own working cells, you can take that as a guide and build probably at your own facility. And whatever software will be created, we'll have tested containers which you can download and use it probably in your case. We also have commercial offerings for customers, where we'll provide testing and experimentation services in the line of assembly, welding, manufacturing automation, robot accuracy, and so on and so forth. Yeah, so this is how the timeline is going to look like. So probably we'll have the first cell set up by end of this year. And also we'll release the software composition by early next year, but let's see how that goes. So this was about AI Matters quite in short. Bjorn will be presenting that later today or tomorrow, I'm not sure, tomorrow. But yeah, if you have any questions right now, you can get in touch with him. Another development that, again, my colleague Christoph and Vishnu have been working on this year, since last year actually, is basically porting of the ROS2 CANopen, the CANopen stack in ROS from 1 to 2. We are almost ready for the beta 2 testing release. We have also try to test the CANopen stack on the PRBT robot. So the driver was available in ROS1, which again my colleague has been also involved with in porting it to ROS2. Yeah, the driver almost works. Still some issues with vibrations, most probably something to do with real time. So if somebody is an expert here, please get in touch with us. And yeah, so underneath, basically in ROS1, the CANopen stack was custom built, but now we are relying on an existing Lely libraries. And yeah, so there is also ongoing work with integrating it with ROS2 control. Dennis here has been quite helpful with that. He's been actively involved in doing the integration. And yeah. So I'm almost at the end of my slide. So upcoming events is basically, yeah, so after COVID, very recently, I think from this year, if I'm not wrong, we started with the ROS meetups again, which was dormant for a long time. And Christian, my ex-colleague here, will be organizing this event in Renningen on 26th of July. So I think my team will be there. We expect, if you are in Germany or you're really excited to come to the event as well, please come to Renningen. Yeah, I'm definitely excited about this. All right, so that was it from my side. If you have any questions right now, or you can also get in touch with my colleagues, which I already mentioned, for any specific topics they want to
So we
talk
have
about.
time for about 5 minutes time or so for questions.
So regarding reference cells, what would be very cool that all the parts are basically standard components.
Yeah.
That would be like my wish. Basically that you can buy them then for multiple.
Definitely, that is definitely the idea, yeah. So the system integrator would basically just, would buy these components off the shelf, and based on the customer's requirement, just assemble them together. That would be the idea for sure.
Yeah. No, but also what I mean, they are like norm elements in building stuff in mechanical engineering, and if you are using such things, then you usually have multiple companies you can order from, and this is then great because we all lived through delivery shortages, and I think we don't want to have it
Yeah.
on this. So this would be very nice. Yeah.
Thanks for the talk. Yeah, my question is, for the reference work cell, are there plans to be able to swap out the arms with different mounting patterns without Swiss cheesing the welding table, or is there already some mechanism for that?
Yeah, so we are still very much in the early stages of the project. So of course that would be the idea, because we want to have kind of a plug and play cell. But right now we don't have a solution, because we have just started with the discussions, trying to see what are the requirements. So we are just collecting all the requirements and trying to create a specification. But definitely that would be part of it, because we are buying multiple hardwares in the hope of, not in the hope, but with the expectation that the customers will want to test a particular application, let's say with multiple robots. Not at the same time, but like swap it out and stuff like that, and that will be definitely considered.
Yeah, that'd be really useful.
Yeah.
Thank you.
Have you approached any of the robot manufacturers that you mentioned, see whether they would be interested in collaborating? You mentioned something about drivers, for instance. I mean, it seems like you have an idea of what sort of functionality you would like. Seems like a good opportunity to get them involved. Lots of money also. They typically tend to be very motivated by money.
We actually are right now just contacting them and trying to get a quote from them. But we are still creating a list of features, what is required. There was recently fortunately, I don't know, but surprisingly, there was a requirement within my department. And as soon as they realized that we are buying these robots, they asked if the ROS driver supports velocity control, for example. We haven't created a list of features, what we expect. But that is in the process, but I don't know if there is a plan to collaborate with these manufacturers. Vishnu? Is there a plan to get them involved in some way, or we are just treating them as a vendor from whom we buy the hardware? The question from Heis was that it would be nice to get them, get the OEMs involved and collaborate with them, I don't know, maybe to improve the features of the ROS driver and stuff like that. Right now, are we treating them just as vendors where we buy the hardware from, or is there plans to also have some kind of collaboration with them and get them more deeply involved in the project?
Right now, we are just buying the robot from them. So maybe if they are interested to develop ROS driver and improve, contribute to the community, and definitely we will be looking into that.
Okay.
Yeah.
So that is still that is discussed already, and you might do that later in the future. Okay.
Okay, so I think we are end of time. So thanks again for the speaker, and then we prepare the next talk.